Before we get into this, here's something most people don't realize. There's one map, just one, that pretty much tells you whether you're getting storms, sunshine, snow, or a completely chaotic day, and it sits about 18,000 feet up. This is the 500 millibar map. Right here, you can see these broad waves, ridges and troughs rolling across the atmosphere. Ridges push north, troughs dig south, and everything we experience at the surface gets pulled along for the ride. That's why meteorologists call this level the steering wheel of the entire atmosphere. It shows where systems want to go, how fast they'll move, and whether they are gearing up or dying out. So in the next few minutes, I'm going to break down what this map actually shows, how to read it, and why it's easily one of the most powerful forecasting tools we have. Alright, let's talk about what you're looking at when you see one of these maps. The 500 millibar level sits around 18,000 feet. It's high enough to filter out the messy details from terrain, but low enough to show the flow that drives almost everything we feel at the surface. This chart has three features that matter. Blue height contours. These outline the shape of the atmosphere and highlight ridges, troughs, and closed lows. Black wind barbs, showing the direction and strength of the mid-level flow. And finally, the red isotherms, marking temperature at this altitude, which helps see where cold and warm air pockets are hiding. This particular map is from October 26, 2010, one of the most intense cool season severe weather days on record. Just look at the reports on the left. Tornadoes, widespread damaging winds, and a crazy tight pressure gradient. On the 500 millibar map for that morning, everything lines up. A powerful jet streak carving into the base of a deep trough, another jet streak reinforcing the backside, and an extremely dynamic wave pattern. That setup is why the storm system deepened so fast and why the severe weather was so widespread. When something big is about to happen, 500 millibars almost always tells the story before anything else. Once you know what's on the map, the next step is spotting the big players. Troughs, the dips, bring rising air, cooling aloft, and more active weather. This is where storms, cloud cover, and unsettled conditions are most likely. Ridges, the bumps, are the opposite. They're all about sinking air, warmer temps, and quiet, stable weather. And then there are closed lows, where the contours fold into a circular shape. These systems move slowly and can lock in the same weather for a couple of days. Rain, snow, clouds, wind, you name it. So what's the first thing you do with any 500 millibar chart is just scan and ask, where's the ridge? Where's the trough? Is there a closed low? Those three answers alone give you a huge head start on your forecast. Now we layer on vorticity, which is basically a way to measure spin in rising motion. These shaded colors represent positive vorticity, and that's where the air is lifting and spinning, the fuel storms love. The darker the shading, the stronger the upward motion. Around a deep upper low, you'll see tight pockets of strong vorticity. That's your storms want to form here zone, which is why you see the thunderstorm icon sitting there. Farther downstream under a ridge, there's barely any vorticity at all. That's where you get clear, quiet weather. And those elongated streaks of higher vorticity ahead of a trough, that's where forecasters start thinking, if moisture and instability show up, this area could go. It's a heads up before the storms even exist. Once you combine vorticity with the overall pattern, you're basically watching the atmosphere hint at where it wants to get active. So here's the big picture. The 500 millibar map matters because it shows the overall weather pattern better than anything else. This wavy jet stream explains why one part of the country gets storms, another gets sunshine, and another gets snow, all at the exact same time. At this level, you can clearly see how the upper flow connects to the surface weather we actually feel. It helps us figure out where storms are going, how strong they'll get, where the atmosphere is supportive, and where it's shutting things down. It also tells us where storms are likely to strengthen or weaken, because mid-level wind patterns control lift, spin, and how fast air masses move. That's why this is the atmosphere's steering wheel. everything underneath it, fronts, surface lows, storm clusters, snow bands, follow the flow you see here. If you want a follow-up video where I walk through how to read a 500 millibar map step by step, line by line, let me know in the comments. And if you enjoyed this breakdown, hit like, subscribe, and share it with someone who loves real weather analysis. Thanks for watching, and I'll see you in the next one.